In the last lecture, we saw what happens in the JavaScript engine once we run our code and how it is parsed and then converted to machine code. Now let's focus on the order in which the code executes, and for that, we need to understand execution context. All JavaScript code runs in an environment, and these environments are called execution context. So you can imagine an execution context like a box or a container that stores variables and in which a piece of our code is evaluated and executed. We will go more in depth in the next slide. Now, the default execution context is always the global execution context. Remember how I just said an execution context is the environment in which a piece of our code is executed. Now, related to this, always remember these 4 points and understanding the execution context will be easy. The default execution context is always the global context. So, this is the start of the execution. Every program starts with the calling of the global execution context. To make it more simple, you can consider it the main function from where the parsing starts. Remember that I just said that an execution context is where a piece of code is executed. Well, in a global context, all the code that is not inside of any function is executed first. And this is very important. So again, the global execution context is for variables and functions that are not inside of any function. And this will become clear just in a moment when we will see the code execution representation. Now, you can also think of an execution context as an object. Remember objects from the introductory lectures? So, the global execution context is associated with the global object, which in the case of the browser is the window object. So, everything that we declare in the global context automatically gets attached to the window object in the browser, and it works like this. Declaring a variable called myname or window.myname is the exact same thing. It's like myname is a property of the window object. Now, we all know that properties are just variables attached to objects. So this makes sense, right? Now I know that these all may be going over your head. So it's completely normal. I will suggest you to take notes and read these terms word by word and line by line and try to find the resemblance between them and give it some time. It will all make sense. You can come back to these lectures anytime in the future. These are not going anywhere. And if you have doubt anyway, you can ask me in the comment section. Again, remember the global execution context is for code that is not inside of any function. But what about code that is in functions? It's actually very simple. Each time that we call a function, it gets its own brand new execution context. Okay, now let's see an example and then it will all make sense how the code execution works. So this first declaration of channel name variable is not in any function. So we are in the global execution context. The red arrow is pointing to that. So this variable is stored in the global object. We will see how that works in the next lecture. Next up, first function, the second function and the third function. These 3 functions are also in the global execution context. So all of the global data are stored in this global execution context. And now this is where the fun begins, because here is where we have called the first function. So again, remember the rule. A new function gets its new execution context, which means a new execution context for this function will be created and it will be put on the top, forming the so-called current execution stack. Now, for the duration of this first function call, the execution context for that function becomes the active context in which the code is executed. So let's get inside the first function with our arrow and see what is inside that function. So this a variable will now be stored in the execution context for this function and not anymore in the global code. In simple language, all the code described in the first function will be stored in its own execution context. Now, inside of this first function, we are calling the second function, and I hope you are ready with your guess what will happen. Yes, again, a brand new execution context will be created and put on the top of the execution stack. Because we are calling a function and each function gets its own execution context in which their code is stored. And now this becomes the active context. So in this function, we have variable b stored in this new execution context, and now we call the third function inside of the second function. And once more, a new execution context is created and put on the top of the stack. And now this becomes the active execution context. So inside of the third function, we just have few variable declarations and nothing much. So it will be stored in this execution context. So this function has now done all its work, and so we say when a function is done, it returns. So what happens to its execution context? Well, it simply gets popped off the stack. Then the context of the second function, which called the third function, is back to being the active context, and we go back to the second function. So this C variable gets stored in the current context, and after this function returns, this context also pops off the stack. And now we are back to the first function, and here the same thing is happening. So the function is done, it returns, and so we exit it, and the execution context pops off the stack. And this is how all the code gets executed. All three functions created three execution context and popped off the stack when the function returned. And once all of the code is executed, we then mark our program to be finished, permanently popping off even the main context. It truly marks that our program is finished doing the task it was intended to do. I hope that all of this made sense to you. Now you may ask, how are all these execution contexts actually created, and why is this so important? So let's now take a small break, and in the next lecture I will show you how the execution context is created. In the last lecture we saw when an execution context is created, but how does that happen? Let's see now. Let's start by creating a representation of an execution context so that we can have a bit more details of how it works. We can associate an execution context as an object, and this object has three properties: variable object, which will contain function arguments, inner variable declarations, as well as function declarations; the scope chain, which will contain the current variable objects as well as the variable objects of its parent, and then the this variable. Alright, so how is an execution context created? So let's first revise what we already know. That is, each time a function is created, we get a new execution context and it is put on the top of the execution stack, right? Now this happens in two phases: creation phase and the execution phase. In the creation phase, first we have the variable object. We will talk about this in the next slide. The creation of the scope chain, and lastly this keyword is determined and set. So basically the properties of the execution context object that we have here in the left side are defined. Then in the execution phase, the code of the function that generated the current execution context is ran line by line, and all the variables are defined. If it is global context, then it is global code that is executed. So let's now look at the creation of the variable object in the creation phase. So this is what happens in the creation of the variable object. The argument object is created containing all the arguments that were passed into the function. The code then is scanned for function declaration, and for each function a property is created in the variable object pointing to that function. This means that all the functions will be stored inside variable object even before the code starts executing, and this is very important for you to know. And lastly, the code is scanned for variable declarations, and for each variable a property is created in the variable object and set to undefined. And these last 2 points is what we commonly call hoisting. functions and variables are hoisted in JavaScript, which means that they are available before the execution phase starts. They are hoisted in a different way though. The difference between functions and variables is that functions are already defined before the execution phase starts, while variables are set to undefined and will only be defined in the execution phase. Now, just to recap all of this once again, each execution context has an object which stores a lot of important data that the function will use while it is running, and this happens even before the code is executed. Let's see all of this by writing code, and we will start with hoisting because this confuses a lot of beginners even though it is fairly a very simple concept. So let me explain that to you.